Okay, here goes. F prime of x equals the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. I will provide you with that particular limit definition. It's far more important to me that you be able to apply it. I mean, it'd be nice if you could memorize it. It's not that difficult to memorize. But if you miss this one, I don't want you to miss it simply because you didn't memorize it correctly. Spent a lot of time trying to find the limit of the wrong expression. So I'll provide that expression for you on the test. This is the limit as delta x approaches 0 of, well, take the x plus delta x and substitute it for x squared in the denominator, and then minus x squared there, and that's all over delta x. Again, pretty quickly I want to deal with a complex fraction. Dividing by delta x can be rewritten as multiplying by 1 over x. So this equals the limit as delta x approaches 0 of 1 over delta x times, I'll copy and paste, 1 over x plus delta x quantity squared minus 1 over x squared. Should kind of feel like what we did last time. At this point, we had the difference of two fractions, and we got a common denominator, and we subtracted the fractions. Going to do that same thing here. So it's going to be the limit as delta x approaches 0 of 1 over delta x times, well, the common denominator is the product of the denominators. I think I'll write it this time x squared times x plus delta x quantity squared. So looking at the denominators, the first denominator can be multiplied by x squared to equal the LCD. So x squared times 1 equals x squared. The second denominator, x squared, can be multiplied by x plus delta x quantity squared to equal the LCD. So that is what we need to subtract, x plus delta x quantity squared. No radicals here, so we can simplify the numerator and cancel some terms and hope that we have a factor of delta x that can be used to divide out the factor of delta x in the denominator. So this equals the limit as delta x approaches 0 of 1 over delta x times x squared minus, and kind of important here that we're subtracting a quantity that we're about to simplify. It's already multiple terms, but it's going to become a trinomial. When it becomes a trinomial and we lose the exponent right here, we still need parentheses around that trinomial expression that results from that. So we square the x and we get x squared. We take twice the product of the two terms and it's plus 2x delta x, and then we square the delta x. Now at this point I think I want to copy most of this, clear the parentheses, and then do a little simplifying, a little bit of erasing, save ourselves a little bit of time and effort. It's going to be x squared minus 2x delta x minus delta x quantity squared over the LCD. I don't know if you're following your notes at 3 o'clock some morning, a few days from now, are you going to know what happened if I just erase the x squared and the minus x squared? Maybe you want to erase them on your paper. Maybe you'll recopy this, and it makes me feel just a little bit irresponsible to do that. So I don't. I did it on the previous problem. Maybe I shouldn't do it in this one. Minus 2x delta x minus delta x quantity squared. I know it's an extra step that has to be written. There we go. You can imagine that I just erased the x and the minus, the x squared and the minus x squared. So they're gone now. Is delta x a factor of every term that's left in the numerator? That's what we need. And it is. So we factor out that delta x, so it's going to be the limit as delta x approaches 0 of 1 over delta x times, let's see, yeah, delta x times negative 2x minus delta x all over x squared times x plus delta x quantity squared. Finally, we can divide out the delta x's. In particular, we can divide out the delta x in the denominator with this delta x in the numerator. As soon as we do that, the denominator is no longer approaching 0. So we can evaluate this limit using direct substitution. So I'm going to write the simplified form, and then we'll use some direct substitution. So the two places where we see delta x, we'll substitute 0. So this equals negative 2x minus 0 over x squared times x plus 0 quantity squared. And this is going to be negative 2x over x squared times x squared. Now, a step we might skip is the step where we write negative 2x over x to the fourth. Or should I write negative 2x over x to the fourth? I should write that, huh? Negative 2x over x to the fourth. But then we immediately realize we can reduce that one more time to what?
Negative 2 over x to the third.
There we go. Negative 2 over x to the third. Negative 2 over x to the third. And that's going to give us the derivative there.